and address this question in some way of, you know, where did human beings come from? Because, you know, there's a lot of... Huh? No, I'm not going to, no, I'm just going to hit some points that maybe to think about. And again, the way to look at this is, well, you have to ask yourself, first of all, see, this is a very interesting thing. Let's look at the following problem in terms of the way people think about this stuff. People say, where do human beings come from, as though you can just sort of answer it, right? Say, well, all right, and then we're supposed to go trace out the lineage, sort of people today. And we're supposed to, it's sort of, people think of it like finding the source of a river. You know, you're going to go up the Mississippi until you can find the spring water in, I don't know, upper northern Minnesota or wherever it is, that is the source of the wellspring of the Mississippi River. First of all, you know, there's even complexities to that, but you can look at that. Now, so people sort of think, let's take the population today, and let's trace the lineage back. You know, one of the biggest things in people's minds now is genealogy. Very funny thing, genealogy. So the idea is we're going to go back and we're going to trace it back and back and back and back, and we're going to find sort of the original human being from whom everything else sprung. Of course, then the problem you get into is the typical problem. Well, wait a minute, where did that come from? I mean, did that just come out of nowhere? Okay, now that we got that, we got to go back and back and back and back and find out where that came from. And you're just going to keep doing it. The problem is you don't know what you're looking for. Actually, there's a funny point about genealogy. You know, the greatest people, everybody who goes into genealogy, the greatest single compilation of genealogies, at least in the United States, is in Salt Lake City. The Mormons have, you know, because they're very fascinated with genealogy, there's a somewhat of a, I would say, you know, a somewhat racial conception of this kind of thing. You have to, in order to know who you are, you have to know the compilation of all the people who produced you. It's sort of, it's not unlike what's in people's minds today in general. I have to find out what my genome is, my entire genetic code, and where that all came from to know who I am. See, the problem is, if you want to ask yourself, where did human beings come from, you have to ask yourself, what is human? This is not, these are things that are not statistical correlations, or not simply lining up all of the bits of data, because what's human? Where does humanity, how would you identify the existence of something human? And you can get into a lot of trouble on this. There's all kinds of stuff that floats around that really doesn't make as much sense as it appears to on the surface. Because, for one thing, you get into the following kind of problem. Here's an interesting way of looking at it. Human infants, on the one hand, I'll come to something else, but human infants, up to a certain point, have a sort of developmental characteristic that's not unlike infant primates. That is, a chimpanzee can do a lot of the things a human infant can do up to about 12 months or 18 months. In some ways, in terms of muscular coordination, they're a little quicker. Now, does that mean, because we can identify certain characteristics, that there's something human about the chimpanzee? Now, the problem you have to ask yourself is, if you're asking yourself, how did human beings come into existence, you have to ask yourself, what is it to be human? And get less hung up on certain things like the physical characteristic. Because, for example, if you just look at a physical correlation, you get caught up in all kinds of problems. For example, suppose you have somebody who has all the characteristics and all the ability to be human, but for some reason doesn't act like a human being. for example, doesn't learn beyond a certain point but has all the physical characteristics. What is it to be human? How do you define humanity in order to find out where it comes from? And you're going to find something totally different than you think. Now, let me give you another way of thinking about this, and then I'll tell you a funny little aside in terms of the way these things work. Most people are taught, although some of this has been shown differently, but most people are taught that Copernicus discovered that the sun was at the center of the solar system. And then you're supposed to then look at historical developments in astronomy from that standpoint. Okay, after Copernicus, you had Kepler, who came up with a couple of weird ideas, and then you had Newton, who got the mathematical formula right. And therefore, Newton is the discoverer of science. Now, the truth of the matter is that Newton is pretty much a fraud in the sense that he simply derives algebraically from Kepler's three principles something that Kepler had already referenced in the 1609 New Astronomy, the concept of gravity. But the reason Newton is given credit for this is that Newton comes up with the so-called mathematical formulation for gravitational attraction, which is, if you look at the Science of Christian Economy in an appendix, it's a simple, and at one point Newton admits this. It's a simple, you just take the three laws and you do a certain, the three principles, the equal time, equal area for the elliptical orbit, the ratio of the time to the distance from the sun, which is a cube to the square, and I think the elliptical orbit itself, and then it comes out to be, you can derive the gravitational equations from that directly. It's purely deductive. Okay, Newton does a little other trick with the calculus, which is a little more difficult to describe, but that's a simple point. Kepler was the one who discovers the fundamental laws by which the solar system operates. And in fact, it's better to approach it from Kepler's standpoint. Now, what's the problem here? Actually, the problem in part goes back to this idea of Copernicus. Now, Copernicus himself may not, I don't know that much about him. Newton was a bit of a fraud overall. And in fact, one of the most fraudulent elements of modern science today is this idea that you have to have the mathematical formula, and once you have the right mathematical formula, you simply then know that that's what the world is like. So the world has to conform to the mathematical formula, the equation. This is part of the problem with computers. Not that computers can't be helpful in doing this or that, but the problem is, you see this in the learning process in schools. It's a real disaster. This is why you have to know what's human, because people think they don't have to do anything anymore to know something, because the computer will give you the answers. You might have to know a little bit about programming in case you get a glitch, but the computer will give you the answers. You hit the right buttons, you're a little clever on hitting the right buttons, you don't need to run experiments anymore. I mean, one of the classic cases of benchmarking, this idea that you can run everything on a computer, all experiments can be run on a computer, and you don't really need to do actual field experiments. You don't need to test the car, test the railroad, etc., etc. You can just run computer modeling. This has caused great disasters like the Ford Explorer. But the biggest disaster, that's true, the Ford Explorer, they did not do sufficient road testing of the Explorer. And they had a simple problem. They were putting, basically, as this is the killer one. Something. Basically, the Ford Explorer is a Ford pickup truck. That's all it is, with a car on, with a roofing structure on top of it to make it look more like a passenger car. Okay. Now the problem is, it's a little bit like you used to get with the old station wagon. There's two problems. One is you lift up the center of gravity when you do that, so that the point at which the car is going to roll over is easier. And you've got basically the same weighting structures in it and the same spread in the wheels and so on and so forth. Now, they ran this through computers and it came out all right. The problem was it doesn't come out all right. It also changes the pressures on the tires and so on and so forth. But the worst element of this is education, because you get people who never learn how to design a physical experiment, never know how to deal with an anomaly, basically they sort of treat the computer the way you do your car when it breaks down. You kick it. You say, gee, if I kick it in the right place, maybe it'll work again. It'll give me the right answer. And plus, people believe that what the computer gives you is the answer. So, for example, you try to get across the concept of the unique quality of what we call a transcendental number, pi, which cannot be written as a non-repeating decimal. You need an infinite repeating decimal. Most people these days don't even get the point because they figure, look, I know what pi is. I punch the computer. It prints out a number to X number of digits, and that's what it is. That's all you can get. That's what it is. I don't get the concept of something beyond that. Now, the problem we face, and this is why Lynn has put forward a lot of these pedagogical ideas, is real thinking is overcoming precisely the kinds of anomalies, paradoxes, that are ruled out by the acceptance of this purely linear, repetitive process, or what is often statistical correlations, like this point I was making about some of the studies done on these carcinogens and so on and so forth. I mean, just to take an example, you take this question of the genetic code. So you know, people will say, we have the following gene, and this gene seems to have something to do with regulating a mechanism that in one way or another might cause cancer or stop cancer. And so then you look at the fine print on this thing, you realize that there's a real problem in it, even if it's accurate. They say, well, if you have this gene defective, you have 100% more likelihood of getting cancer than if you don't. Okay, that sounds horrifying. I mean, you virtually feel like if you find you have that gene, you're going to die tomorrow. Of course, that is the state that it induces in people. Now, what you then find out is that the likelihood of getting this cancer in the population is 1/2 of 1%. And because you've got this gene, you have a 1% chance. Well, doesn't make you feel more comfortable, but it's slightly different than thinking you're going to die tomorrow, or that necessarily you're going to wake up someday with this cancer. All you have is an increase that's a 0.5% increase. It means, for example, that whatever role the genetic factors play, there are many other complicated, complex factors in the living organism's relationship to its environment that may well be more significant than the gene itself. I would even propose to you that the psychological condition of the person has a certain psychosomatic relationship to the presence or non-presence of the disease. Not because I think there's some kind of mind power, but because the human organism has a highly complex active central nervous system. The state of that central nervous system, the degree of energy, the degree of activity, the health of that is a core part of the health of your immune system and other physiological factors that are generated by the level of mental activity. So what do you have? You have a statistical correlation. What do you really have with Copernicus? What do you have with these people other than Kepler? The problem is, first of all, Copernicus did not discover the fact that the sun was at the center of the solar system. This was known to the Greeks. It was known to Aristarchus. It was generally known to a whole grouping amongst the Greeks. It was hypothesized even merely 60 years earlier by Cardinal Nicholas of Cusa, who had a heliocentric system. Now, the problem is that the Copernican system and the system of Tycho Brahe, who had a slightly different version of it, okay, these things were all based on a concept of uniform circular motion. That is, the assumption was that the mathematical model that we had for activity in the universe was uniform circular motion. And what the characteristic of circular motion is an equal amounts of motion of the arc. You know, if you rotate on the circle, you cover an equal amount of arc. So as you rotate around the axis, Every angle of rotation gives you the same amount of a distance of arc. Nothing ever changes. The velocity doesn't change. Everything is the same. Now, this was considered to be an assumption about the proper mathematical model or geometric mathematical model for the way the universe functions. So what did Copernicus and others do? They forced the motions of the planets and so forth to conform to that model. So, for example, what was the center actually of the solar system in Copernicus? It wasn't really the sun. The character of the sun was it was the only part of the solar system that didn't move. But it wasn't the center of the circle around which the Earth moved. The center of the Copernican solar system was a point. And there was no other efficient relationship between the sun and the motions of any of the other planets in their orbits. They were governed by mathematical laws. Okay? That's not Plato. Contrary to what people think about Plato. That's contrary. That's Aristotle. Fixed laws, fixed formal logical laws that the systems have to adhere to. So there are a whole bunch of things in this. For example, this is what they call conforming to the appearances. There were other anomalies that were known. And this is a perfect example of anomalies, and you have to put yourself in the mind, how do you deal with this within the existing accepted formal system? So, for example, if the Earth is supposed to be fixed and at the center, if these things are all supposed to be circular, we notice something as we observe, let's say, the planet Mars or any of the outer planets. It's an interesting, simple phenomenon. This becomes very complicated if you have to adhere to a fixed mathematical formal system. When we observe Mars in the sky, Mars appears to move backwards at certain points. It loops around. It changes its distance. Now that's simple. By the way, that's not complicated. How did Copernicus account for it? He put circular motion on top of circular motion. So, for example, a planet like Mars, here's the circle of its orbit. But since it seemed to exhibit odd motion, how do you account for that with only circular motion? Well, he created epicycles. So that really Mars itself is not in this orbit. But the orbit of Mars is the center point around which the planet rotates. Okay, so now you have two motions. You have the circular motion of the orbit, and now the planet Mars is orbiting around that orbit in a circle, in a circular motion. So you get, if you try to trace this out, if you have, this is the circle, Mars is orbiting around the center of the orbit as a circle, right? Now this is the center point of Mars's motion is moving. So what does Mars' motion look like? So you get the loops. Then you can trace this out. You can do a little experiment for yourself. Now, why is all this mechanism there? Because the formal system, which is the accepted mathematical knowledge, demands it. Now, by the way, now begin to think about these arguments about economics. Well, since the free trade, unregulated system is the only system that can work, and everything else is ruled out. We actually had somebody walk out this morning on the basis of this, right? Because the question was, what credentials did Harley and I have to talk about economics? Because they had economics at a university. Well, what are our credentials? Well, you could say, go through our credentials. University of Wisconsin, this, first of all, it's so long ago it doesn't help anyway. But anyway, University of Washington, whatever. Okay? But what about the credential that the economic outlook that we're presenting to you was by the only successful forecaster of the last 30 years? That doesn't mean anything. The fact that the bubble blew up doesn't mean anything. The fact that the new economy disappeared, we're going to re-rig the discussion. The new economy was meant to never have a recession point. Well, it did have a recession point. Okay, we're going to change we're going to change the reality to fit the mathematical model. And that's a lot of what drives people crazy in these arguments. They're really saying to you, no, it can't be that way because this is what the formal system says. This is what the mathematical model has told me. The universe is like this because this is what the mathematical model told me. And of course, nothing is more like epicycles than, and you know, Copernicus' system had 39 epicycles in it. It had more epicycles than Ptolemy had in his system. And that was with the Earth at the center. Okay? This is the truth of the matter. What Kepler said is, no, we have to find the physics of the universe first. And we're going to then discover the mathematics that we need. And that's really, in the sense, that was revolutionary, brilliant. He said we're going to look for a physical principle. What is it that could possibly tell these planets to move in these kinds of orbits? To give it the coherence. And this has a certain structure in terms of the motion and in terms of the harmonic relations within the solar system. Now, what kind of principles, universal physical principles, would tell these planets to operate this way, in effect? The universe tells it to operate that way. Principles of least action. Principles of proper coherent motion, because remember, all the planets are in motion affecting one another. So the harmonic ordering of these things is important to the stability of the structure as a whole. So what does Kepler do? He says, well, let's look for some real physical principles. First of all, you're going to have a relationship between the sun, as in a sense the motive center of the universe, of the solar system, and those planets. It's the sun, in effect, or the relationship to the sun, as a physical generator, which governs the motion of the planets. Now, however, there was no way of relating those motions in a simple, coherent way by simply having the sun at the center of a circle. So he had to figure out a relationship between the sun and the planets, which no longer gave you simple circular motion, based on the observations and relations, and based on the anomaly of the relationship between Mars and the planet Earth. That is, if you try to keep it circular, no matter what you do, you have a certain margin of significant measurable error of about 8 minutes of arc. So he, after playing around with circular motion and the idea of the sun as the motive force, he realized that given this anomaly, we're going to have to do something revolutionary. It's not going to be uniform circular motion, but we're going to relate it to the sun as the physical force, as the center of these universal principles. And so he decided, he said, we're going to work with elliptical motion, but we're going to demonstrate that the elliptical motion comes from the relationship to the sun. And what's the universal principle involved is, generally speaking, equal time, equal area. That is, in a sense, in an equal amount of time, an equal amount of work is done in the relationship between the sun and the planet. That there can be a changing relationship of velocities to distance. So you have an acceleration, a constant acceleration and deceleration based on the relationship to the sun. That was precisely the principle that Kepler enunciated in the 1609 New Astronomy after he'd gone through all this. Really been working on this for about, at that point, about 15 years. By the way, a very powerful point in this, even for younger people, is you have to work on problems to make discoveries. He worked on this and worked on this and worked on this. He started with the Mysterium Cosmographicum in about 1595. He'd been working before then. He started out with circular motion, simple relationships between the Platonic solids, and so on and so forth. He ended up with something quite different by 1609, though it was based on those original principles. Now, he said, now we have a problem. And I think this is very interesting because it's totally different than the way people think about it. Now we have a problem. I don't have the simple algebraic mathematics to handle that. I can give you a geometrical picture. I can try to add the motion up by taking an infinite number of little pieces of arc and areas, and what's the area and what's the distance and what's the time. But I don't have the mathematics for this. It's a totally different principle. It's a principle of least action. It's a principle of commonality of work or a relationship between distance and area, between time and area. But we don't have the mathematics for this. Well, at the same time, a series of other similar problems were coming up. You had the problem of refraction. Light does not move in a straight line. I'm not going to go through all this. But it turns out that light is refracted from a principle not of the shortest distance, but the least time. Now, that's something to really think about. Because if you let yourself think about it, it's going to rattle your cage a little bit. Because everybody knows the shortest distance between 2 points is a straight line. Well, okay, if you take everything out of the universe, then you're left with Euclidean geometry. But then there's nothing left of the universe. It's just an empty box. And that's not the universe. So if you want to deal with the real universe that has all kinds of processes in it, interrelating processes, then you have to look at the question of, okay, when I shoot a beam of light from the air into water, it changes its angle of descent. It changes it in a lawful way, but not in a simple way. It changes it in a way that's related to the angle at which it enters. And it chooses a path of least time. It's also related to what you got in the water, so to speak. Now, these kinds of problems, problems of other sorts of problems like the catenary problem. If you take a hanging chain and you hang it from 2 points, it creates a curve that is undescribable in the form of simple, smooth curves. You need to know something else about it. So all these problems come up, cycloids. And in the 17th century, particularly led by Kepler, his question, he posed this, he said this, by the way, this is one where I'm not making up. One good thing about Kepler is you don't have to make things up. He says, somebody's got to work on this. We don't have the mathematics for it, but this is the way the universe works. So let's discover the mathematics. And then simply put, what you had was people like Bernoulli, Huygens, Leibniz, looking at some of these actions in the real physical universe that was now characterized by a least action, least time principle. And that's how they discovered calculus. The mystery of all mysteries that screws everybody up at some point. But they were trying to figure a way to look at something that was changing in the small at a rate that was governed by certain physical principles in the universe. And so you could come back and find out what that change in the small was if you knew what the principles were that governed the entire arc of action. And so really, for example, there is a relationship between integral and differential calculus. They're really inverses of the same thing. And actually, in the 17th century, they always started with the integral, not with the differential, the way most of you were taught. How many people have taken calculus and recall it? You start out with the differential, right? That's what you always do. Well, in fact, historically, they started out with the integral, the entire action, arc of action. And from that, they looked at how you could define the change in the small. What?
Integral, that came first, right? So
Yeah.
like hydrogen came after differentiation.
Right?
That's how people were.
Right.
Integral, like, it had nothing to do with differentiation.
No, it wasn't differentiation. Differentiation comes from the integral. Historically, that's what it came from. No. In fact, the way Leibniz and these guys, the way Leibniz discovered the calculus was he worked on the concept of the integral and looking at the catenary curve and related logarithmic curves. And then he developed the idea of what the ds, the differential in the small. That was the actual history of the calculus, they weren't separate. If you look at what these guys, there's a paper by Leibniz on the catenary curve, which works on this problem. So I think you have to look at that. But that's really the history. Most of the history of this stuff is not right. Carl Boyer's history of the calculus is wrong. And that's the standard history of the calculus. Okay? I mean, look, one of the things you have to do is go to original sources. I mean, it's all right to look at secondary sources, but you always have to go back to the original sources. And you find that what these guys... Bernoulli does a textbook on calculus in about 1680 or 90 or something like that. And it's very clear. He starts out with the integral and moves from the integral to the differential. So to me, the more interesting thing in this is Kepler says we need a new mathematics. Once in a while, you have something. For example, you have a case in mathematics where somebody discovers the number I because it just turns up in an equation. You know, the imaginary number, the square root of -1. Some of you may be familiar with it. Anyway, what's the square root of -1? You don't have to be a genius to figure this out. What times itself equals -1? You know the rules of algebra, of addition and subtraction. +1 times +1 is what? 1. -1 times -1 is 1. At least that's the rules that you're taught, right? I'm not going to ask you to say, I understand that. In a sense, you can think of an inversion of an inversion. That's really what the negative process is. Okay? It's sort of, you know, a good way to think of it in language? I'm not going. So the idea of two negatives meaning a positive, you're more familiar with it than you think. I'm not going to give this up. Yeah, it's interesting. It's not so strange, but you have to. The reason it's strange is they never tell you what it is. So if you think of negative as a rotation in another direction, if you go in a negative direction, you're rotating your first direction 180 degrees. Then if you take the number and just realize the negative sign is a rotation another 180 degrees, you're back you're going in the same direction you started. Now, okay, -1 times minus what? Now, -1 times +1 is -1. But that's not the same number. That's not what a square root is. Now, it turns out in certain equations, the square root of -1 comes up. You don't have to be a genius to figure that out. It comes up in certain kinds of famous equations in the earlier period, in the 15th and 16th century. But it was dealt with as a crazy number. It was just a solution to an equation. It didn't have any meaning. It didn't mean anything. It was just an imaginary number. Think of the word. It's like the idea of an irrational. The square root of 2 is irrational. Now, you can look at it one way and say it just means it doesn't have a proper ratio. But what do most people think? Irrational, imaginary, crazy numbers. Okay? But the fact is it represents something real. You have to figure out what it is. The square root of 2 represents something, a fundamental physical action. Think about where the square root of 2 comes from. Okay, the square root of 2 is the hypotenuse of a right triangle with legs 1 and 1. Right? What is really happening? How do you form that? You cannot form that by taking any simple straight line. It requires something done to the straight line. There's no internal way of piling the line on top of itself in some ratio that gives you the square root of 2. If you take 1/3 of the line and put it up, you get a ratio of 2 to 1. You're not going to get a ratio that's the square root of 2. The only way you get the square root of 2 is the physical action of rotating the unit line 45 degrees. And you get a 45-degree right triangle with the legs 1 and 1, and that generates the square root of 2. It represents a different power, a different physical action. Numbers, properly understood, are always an outcome of an actual physical process. And these physical processes generate internal relations that require you sometimes to deal with new numbers. Numbers that you didn't consider before that are an outcome of that physical process. And you have to understand what that physical process is. So Kepler said we need a new mathematics. Imagine that. Could you imagine saying to the computer, we need a new, or you can't even say it to the programmer, he just won't, he'll say, no, we can't do that. Okay? Now, if you think about it, much of what goes on in biology and whatnot is precisely this kind of statistical correlation. You're told this is the way it is, and you've got to figure out within that context how do you find a human being? Now here's a problem. How can you get a human being out of a genetic code or a bunch of cells that don't do what human beings do individually or collectively? What is it that gives you a human being? Just moving around doesn't make it human. What gives you something human? What characterizes human activity? What characterizes us as uniquely human? How do you know that when you look at something, it's human or it might be related to a human being? Now I'll give you a little interesting element of this. Because you have to look at what's the nature of human activity. What do human beings do? What characterizes what human beings do? What can you define as human? And then you look for the physical principles, where we came from, and so on. You don't try to impose on human beings a prior fixed definition of something that isn't human and will never give you anything human. It's like what you have in biology when you try to take all the cells. Not only don't you get a human being, you don't even get life. If you take a bunch of atoms, you take a bunch of molecules, you take a bunch of chemicals, you juice it up somehow, it doesn't give you life. Yeah. Yeah, but it doesn't give you life. It's not something that's self-moving. It doesn't give you a coherent living being. In fact, all the ideas they've had of creating life in the laboratory have failed.
So like Henry Kissinger.
Yeah.
Some of the guys who would argue, not me, but some who would argue that is that a certain kind of chemical like lightning and then it turns.
It doesn't. It never happened. Look, this is one of these things. It's a theory. You know how old that theory is? That theory goes back to the 1950s. No, it was I forget the guy's name now. You may. Some guy named Miller, that's right. A guy named Miller said, this was my theory of how, out of the primordial soup, we began the march to life in human beings and so on and so forth. It's never worked.
Yes, some chemicals replicate themselves, though.
Replicating doesn't mean anything.
After a while...
When? Tell me when. When does it happen?
Well, there's that link there.
No, there isn't. This is pure ideology. You're telling me something. I tell you the economy is a disaster. Here's what does it say? No, the economics department says that's not true. It's going to come back. There never was a recession, and it couldn't happen. Now I'm showing you something can happen. You're telling me that if we just let the chemicals replicate themselves forever and ever and ever, at some point we'll get life. No, no one's proven it. No, it isn't. It's not. It's an idiot theory. No, it's not. Pasteur, let me show you how ignorant this is, okay? Look, it's time to really decide that you don't just want to go through college and come out an idiot. Okay, you can go to college and learn some things. Yeah.
Well, isn't it the studies to cloning and the stuff that has to do with cells? Like,
You can clone something, but you're dealing with something that's living to begin with.
but those studies lead sometimes to those type of things, right?
To what type of thing?
I mean, the laboratory and growing all this stuff, doesn't it lead to cloning or stuff with babies?
Look, cloning, here's what we're dealing with. First of all, nothing has been cloned yet. Everything that they've cloned turned out to be defective.
As far as I know, there are cloning humans.
They are cloning, no, not humans.
Yeah, they are.
They haven't cloned humans.
It's like a secret project that you're doing.
No. Well, secret projects we can't deal with. Look, I don't care what you heard. Look at the power of popular opinion. I heard a rumor, I heard gossip, and it's probably true.
Well, actually, I heard the people that were putting the money for it, but they're doing it in Europe.
There's a bunch of religious freaks. There's a guy who's got a weird idea in Italy, who's developed a cult, and it's true, okay? And he's promising people all kinds of things. He hasn't done any of it, okay? It's like this problem. Look, you can't get life. You can take non-living material all you want. You'll never get a living being out of it. It's like look, let me give you an example. This stuff really is awful stuff. And by the way, it is not the only theory. If you read Pasteur, you'll find a different theory. If you read Vernadsky, you'll find a different theory. If you read LaRouche, you'll find a different theory which is more accurate to reality than any of this garbage. If you read Plato, look, let me give you a perfectly good example of this. The same argument is made for artificial intelligence. Huh? What theory? What? No, they're not. These theories that you're going by have been proven wrong for 2,500 years. Huh? More wrong. More wrong. No, this isn't science. This is pure ideology. It's the same thing as your economics classes. I mean, to me, this is one of the great examples. Economics 101 is Adam Smith. He's been proven wrong. By reality. Adam Smith did not create the United States. No, it's not. By the scientific standards of normal degenerate science. I mean, it's like people who insist Newton discovered the calculus. He didn't. It's in the public record. Look, the problem is there's a huge investment that people make in their sense of identity as college students and college graduates. And you've been sold a rotten bill of goods. And frankly, if it's something you just have to deal with. Pasteur hasn't been proven wrong. Vernadsky, let me tell you something. The average professor in the campus year one, they couldn't prove Vernadsky was wrong. They don't know who he is. Ask them. Now, I'll give you a perfectly good example. What?
Well, I just have a question. Like, how did they do it so the whole world bought into this idea? Like, the whole
It's
world
very
goes
simple.
up to the United States,
Pe-
so they think that
because-
they have the highest schools. And how did they do that? How did they change?
Because
the
people believe in popular opinion. They listen to their mothers and their neighbors and every bit of gossip that goes by.
A lot of parents were not
Let me
even
just say something. You just had a presentation before this where I showed that everything they taught about economics in the 90s has been proven wrong by the real economy. So were they right in the 90s what they were teaching in schools, or were they wrong? These were modern theories of economics, that the computer transforms the business cycle and the economy. I showed you conclusively they were wrong. Now what Phil is showing is the same proof of principle in science. Just because someone comes up with a new theory doesn't mean it's right.
Look, this is the same thing is said about, and you can be very quick on this. And look, I know what the problem is in this. You're very susceptible of your friends. People want to look at the question. It's an interesting question. If everybody believes it, How come it couldn't be true?
Well, I'm not saying how come it couldn't be true. I'm saying how did we do it so that the whole world got it?
Not first of all, not the whole world bought it. I didn't buy it.
Yeah, half of the world.
So what?
So I've been questioning it.
A lot of people don't want to think.
If we are creative humans, then theories, it's for other people to experience themselves. You
Yeah,
can't
but-
automatically assume they're wrong. Because
Yes,
then
you can.
don't.
Why can't you if they're wrong?
Because you have to prove them they're wrong.
But what if they're stubborn and they don't want to listen? They're scared. They're frightened. What about? Let's get serious. What about politics? Is it the case that in Germany in the 1930s, I have to now prove that those people were wrong?
Because now they can prove it.
Well, no, but it didn't work in the 1930s. You couldn't prove it to them.
Because people didn't want to stand after them.
Right. Well, okay, well, now you have the answer for now. That's why people don't want to change what they think. They're afraid that they're going to become unpopular. They're going to lose their job. They won't get their degree. Look, there's a lot of stuff in campuses today that are taught as absolute truth that simply wasn't, no one would have accepted a number of years ago.
Yeah, what is your definition of life? You talk about life. What constitutes
Something that actually is able to convert within itself energy into a higher form which it uses physiologically.
the strict definition of something that moves?
No, not moves. You just heard what I said. That's not what they say. Rocks move under certain circumstances. Look, let me make a point. Your head is full of a lot of garbage.
My point is that the chemicals that reproduce themselves, they qualify as life because they reproduce
No,
and they move. That's the biological definition of life.
no, that's not. No one calls those chemicals life.
Ticks can live for millions of years. Well,
Ticks live. They're not just chemical combinations.
but they go to sleep and then but the definition of life.
The definition of life is that it converts energy within a cell or something of that type, which allows it not only to move. That's what it is.
That reproduces.
But can you finish the definition though?
I just did. Okay? It actually engages in a conversion of energy in its relationship to the external environment, which allows it to act on that environment.
That's your definition.
No, that's a class. No,
Accepted.
it is.
The definition of life is movement and reproduction. That's it.
No, it's not. Then I could show you all kinds of things that are not living that move and reproduce, such as chemicals. They're not living. They don't act in any way. Let me give you look at what you've done. Here's what's happened in much science. Okay, they've done the same thing they did with artificial intelligence, and this is very important because look, it is true. While a number of people in the room are not quite as dominated by this, nonetheless, this is the dominating aspect. What's the definition? What's the definition? What's the formula? Here's what the accepted authorities have said. I just showed you that's what Kepler rejected. And Kepler was right. And most people will still want to try to redefine it mathematically from the standpoint of Newton. But even Newton admits that's where he got it from. But that's not important to people anymore. Okay? Now, why is that? Because people are afraid to take on the idea of thinking. And this goes to where human beings come from. And I'll give you an example where a lot of this comes from the United States. Well, I don't want to take the question of artificial intelligence. Okay? Now, if you have a quick question, I'm going to try to finish a sentence here.
Yeah, I was just going to ask you. I was going to say I still don't understand what you're saying. I mean,
About what?
honestly, about how people. Yeah.
I just went through it. You have an organism
Through it, but I still don't
that is able to absorb energy and use it to act on the environment itself. So it not only moves, but it does something to the environment. It's able to eat, move, change its relationship to other forms in the external.
Do that. They run into other chemicals.
No, they don't. That's just a pure formalism, my friend. You're just going to have to deal with that. Okay? Now, what?
Well, I just kind of wanted to I don't know, I just have a comment, I guess. I think thinking about the chemicals, I think that's a real simplistic way of thinking. And I say that only because even though the chemicals may be able to move and reproduce, but see, I think that as people start thinking like that, then eventually people will make the relationship between those simple chemicals that move and a human being. And even though those simple chemicals may be able to move, they cannot make any discovery level. So I think when you want to talk about what is it to be human or what is it to like live, I don't think that you could compare like a chemical that could move with a human being that could make a
Well,
conscious.
the human being is another level on this, but this is really where the problem is coming in. But look, crystals do that kind. They move and reproduce. They're not alive. This is exactly the kind of thing that's going on. I don't think people have any idea, and it's a sad problem, how dumbed down people are in this civilization. Anybody who lives by formal definitions can't think. Now, let me give you a perfect. Now, I'm going to have to go on at this point. Let me give you a perfect example of this: artificial intelligence. Most people today implicitly operate from the same. How would you distinguish a computer, a digital device, that just, if you say, well, if I let it run forever, it'll come up with everything it needs to come up with, or everything that is possible to come up with? That's wrong. And it was proven wrong by Kurt Gödel in the 1930s, 1931. Formally, it was proven wrong by Plato 2,500 years ago. And much of the idea that, all these theories have come along that are new, it's a sad thing. It's often what happens to people when they become too admiring of the power of the United States and they want to replicate it. So they want to adopt the scientific principles of the United States, and they adopt things that are destroying the United States. Okay, now Gödel proved that in fact the formal model of Principia Mathematica and Bertrand Russell, who's another one of these great heroes, who is a fool. And a dangerous one at that. Now what happened was, Gödel proved that you cannot use a formal system, which is the same as the system in any computer you've got. A first-order predicate calculus with universal quantifiers and existential quantifiers and so on. Now the idea was you're going to reproduce all of mathematics with that formalism. Gödel proved you couldn't do it. You couldn't get a formal system that was consistent and could prove all the truths of arithmetic. It was internally impossible formally. Yes. This, have you heard of Gödel's proof? I know, but you haven't heard of Gödel's proof. Because they've written it out in the textbook. Look it up, 1931. Gödel's undecidable proof. Okay? Now, what happened? Why did they have to bury him and that proof, which was only 70 years ago? Because it raises the question that the human mind can generate new hypotheses that reorder the very nature of the ideas that we're dealing with. So what did they do? In the 1930s, you had a bunch of guys who said, well, this may be true. A guy named Alfred Tarski. People like Turing, Alan Turing, who's a great hero to the computer world. Okay? And these guys said, well, maybe there's something in the human mind that's kind of emotional and imaginary and so on and so forth. But all we can know as science, as mathematics, are things that are formally decidable, mechanically decidable. And the way we prove it is this. We show you that every function for which we have a decision procedure, that we know when to stop, or what they call the halting problem in a machine. Okay? If I take all the different ones for which I know I can come up with a decision procedure, Markov algorithms were just a chain of things, certain kinds of lambda recursive functions, they all are the same, they all are actually the same set of functions. Therefore, since all the mechanical procedures that we have give you all the same answer, then human beings can only do, as science, what those formally, mechanically decidable functions can do. So what do? They basically come up with an idiot tautology, a circular argument. They simply define what science is as mechanically decidable. And they say, therefore, all that human knowledge is that which is mechanically decidable. Therefore, computers are intelligent. Therefore, whatever the human mind can do, a computer will do if you do it long enough. And they ignore the entire history of scientific development. of Western civilization, up to and including the proof of 1931 by Kurt Gödel, which if they teach it to you, they'll slander it. They'll tell you that he died a little funny and he was a crazy guy and he had weird theories. And anyway, even if what he's saying is true, there's no way that you can make that scientific. Well, the fact of the matter is, LaRouche made it scientific. This is what he attacked in Norbert Wiener, in information systems. This is what's wrong with society today. It says the human mind doesn't exist and calls that scientific. And that's why people have been dumbed down. They accept this stuff on simple authority. Look, the idea that LaRouche operates by authority is ridiculous. He writes everything. The whole point is that all human activity is intelligible. It's the people in these campuses who are cultists. They say, no, you have to go by this magical rule. You have to believe in this magical formula, and nothing else is acceptable. We call it modern, so if you don't accept it, you're not modern. And everybody wants to be hip, right? Now, the idea that these people have been written, Leibniz, you're not taught Leibniz. You're taught the rationalist philosophers. You're taught Descartes for 10 weeks, Spinoza for 2 weeks, and Leibniz for 2 days. And these days, you're probably not even given that. These days, you're taught. Look, I know what it's like. You go to when I was at the University of Washington, but BC, sometime back then. At 30, what was it? Jesus, 35 years ago. They were just going through a transition. I come from a place that had a little more of a history of ideas approach and blah, blah, blah. So I get there for graduate school in the philosophy department. And what's the big thing that's going on? You no longer have to know anything about the history of philosophy to get a PhD. All you had to know was 20th century British linguistic analysis. Or you could, if you wanted to, you could do 20th century existentialism, but they only had one professor in that course. Yeah, right. The fact of the matter is, you've been sold a bill of goods. Now, this gets you really to the point, even though it's a little bit of a different route than I expected to take. This gives you the point. What is it to be human? What was LaRouche looking at in 48, 50? Why is it when you have this thing here, as Harley pointed out, and I'm not going to overdo this part of it, but whoa, what did I do?
And that just happens. You just have to turn it on.
Huh? Ah, it's not a big deal. See? Maybe
No, this is.
oh, okay. Yeah, one simple point. Why are there two sides to this? Why do we have, what the heck does classical human education have to do with a machine tool? Now, what's the point? Actually, you look at human history. We discover, we create universal physical principles, number one. In other words, we figure out, we face certain kinds of anomalies in our experience, like refraction, like certain kinds of problems that we find in electric phenomena, as Ben Franklin did, like the problem in the way the planets orbit, and we create a mathematical device to deal with non-uniform motion. And all of a sudden, we can deal with all kinds of things we couldn't deal with before. Rotary motion, variations in energy throughput. We're able now to generate all kinds of new technologies. You need, for example, Gauss's complex number field to deal with electromagnetic theory. And so we're able to create this, and then we create the science, and we create, therefore, the physical means to change nature. We dominate nature. We can extract things that are not there to sense perception. You can take rocks, and you can get ore out of it. You can take the ore, and you can create steels. That allows you to create fuselages and trains and cars and rail systems. That allows you to transport things. Air, refrigeration. Think about where we'd be in food if we didn't have refrigeration. Yeah, that's why doing what Harley said, going to one of these places, because people have no idea what it takes to produce something. It's not a question of respecting dirty fingernails. You just got to know how the world works. You look out here at this port. You look at the cranes that bring all the stuff that you import so you can wear it cheaply from some cheap labor. Where do you think those cranes came from? You want to cut back all power usage? You want to cut back all electricity? That's what's happened to this society. That's the education. That's what the decline of this civilization has given you. You no longer, not only don't you know where you came from 2 million years ago, most people don't know where they came from 20 years ago. They think it was all there: the water, the pipelines, the oil, the ships. Well, I don't know. I think a lot of people think it came from outer space. That's also something a lot of people believe. Okay. So what do you have? You actually develop a universe in your mind. That universal physical principle is never going to come from the simple accumulation of what people believed before. What people believed before has left you short of understanding how to deal with that. This is something that goes on in the individual mind. In the case of great discoveries, a new idea is created that builds itself and changes what went before. Now the question is, that's what's human. Beyond that, it's the ability to communicate that idea, and you can't do it in any formal way. You can't even do it in simple linguistic ways. You have to evoke in the other person the experience of the same anomaly, the same paradox, and then the solution to the problem. Yeah. Yeah.
Because everything comes to the same conclusion.
Yeah. But there are different ways to communicate the same idea. Now, however, you're always going to have to try to get the person to relive the experience of the creation of the idea in the mind of the discoverer. There may be different ways to get the person to do that, but they are going to have to do that.
So because I asked this question because sometimes I think when people try to present an idea, they might present an idea in a way in which they could understand. However, when they presenting that idea to somebody else, that person may not understand that idea in the same expression as you understand. So sometimes if you want to get through to people, I mean, this is what I think. If you want to get through to people, you could express the same idea. Well, you could convey the same idea, but just express it a different way. Because I think that's kind of what the problem is when people don't understand.
Look, here's the point. Look, there's a certain amount of truth in the idea. You want to provoke somebody, and you might have to provoke them in different ways. Some people it might be an artistic presentation. Some people it might be a life problem. But there's not different. Ultimately, there's not different ideas that represent the.
Oh, I'm not saying that.
Yeah.
No,
But
I'm the same idea.
I know, but it does mean you can't have the same idea as just the end product. For example, Kepler discovered something about the solar system. There may be different ways to provoke people who want to think about that. But you're going to have to get the person to go through something very similar to the discovery process that Kepler went through to get the full depth of that idea.
Right.
You have to relive what that person went through.
Right,
Yeah. Well, as exact as you can get it, otherwise it's not the same idea. See, that makes it your idea. It doesn't destroy one's identity. People get very freaked out, well, but I have you have your own personality, that's for sure. We all have our own personality. But actually what makes human beings unique is I can actually come very close, though I don't, to taking into my own mind the experience of somebody else, reliving it, and then experiencing that moment where I make the same discovery that person did. Okay? And that's you know what that does? That makes that other person alive. secondly, you experience the joy of discovery that that person experienced. And you find something out. You have a truly loving experience to another person. Because now you're responsible for the joy that that dead person gave you, to keep that person alive even beyond your own existence. And we have a certain kind, that's the soul. It ain't this other thing that people think you're going to try to keep together so you can find paradise. Okay? That's the soul. That's what we mean by passion. Because you have a passion, you'll find yourself with a passion to make that person's life available to other human beings for their own improvement. And I assure you, no digital computer can do that, replicate it. It's not simply a matter of repeating certain formal steps. It's a new discovery. Now, that gives us something in the universe beyond life. You see, they always try to reduce these things to iterative formal procedures. Life is just a series of iterative steps, a simple definition. Creativity really doesn't exist. It's something, it's just an infinite process. You stumble on something by accident, and you may have a feeling associated with it. But I can reduce it to a formalism. No, only in retrospect can you use a mechanism that's a model or a replication of it. Now, what happens? It turns out it's not just the idea. The key to being human is not just the discovery. Because if you were just human by yourself and made the discovery, it wouldn't go very far. Human beings have existed for millennia by the ability to organize other human beings to act on the same idea and to learn that idea, to come to know it, to communicate it for generations. That's culture. You create the circumstances under which such principles of communication become themselves physical principles. What do I mean by that? You take music. You take poetry. You develop it as a means of communicating an idea, not only ideas, but the way to communicate ideas. It becomes a method of communicating ideas. In poetry, it's the method of metaphor, of overcoming paradoxes by generating a new idea. And you develop a culture which develops people whose identity is the creation of ever-improved ideas and the communication and cooperation around those ideas for generations ahead. That's morality. That's the history of the human species. Now, that's what you have to look for when you ask, where did human beings come from? And it's not as difficult as it sounds. You know where we came from? Don't look for it. People get very hung up on this. Oh, you mean you get this, well, I think it's evolution. We came from this and that. We came from the ape. And then there's the other theory. Oh, no. We couldn't have come from animals. We're totally different. So I don't know. Either God kind of threw, the thunderbolt down and we popped out of the ground. Or if you're not religious, then you get into the stuff where it came from outer space. This isn't new. This was, you want to see a perfect example of we came from outer space? In effect, this cult movie, 2001. Space Odyssey 2001 by Stanley Kubrick in 1968. It combined a whole bunch of wacky anthropology theories. Robert Ardrey, territorial imperative, computers, and the idea was somebody came from outer space, plopped an obelisk down, a bunch of killer apes gathered around it. Watch it, it's all there. Okay? They were killer apes. Yeah.
Some were, the other ones weren't.
Yeah, but the ones... But the dominant ones were the violent ones. Okay? No, look, this was a movie that was a brainwash for a generation. The key scene in that, as far as I'm concerned, it all comes from this crazy guy, Robert Ardrey, the territorial imperative, that human beings were inherently violent because their ability to use tools took them beyond their instincts to stop killing each other. So what they do is they get this idea from this obelisk, okay, and one of the apes that just finished killing one of the other apes with a bone, with an antelope bone, or they were so bad, the movie was so bad that it was supposed to be an antelope bone, and they had a taper. They had the wrong animal. Okay. Anyway, so he takes the bone and he throws the bone up in the air. Okay, and you have Richard Strauss in the background. I think it's Richard, one of the waltzes. Ba-dum, ba-da-da-da-da-da-da-dum. And so the bone goes up into the air and it's spinning. And this is how a civilization. You want to know? This is how a civilization gets brainwashed. It gets brainwashed by entertainment. You know, so the thing goes up and it turns into a space station. So what's the idea? Where did you get space stations? Where did you get music? From a violent ape. And a guy in an obelisk from outer space. And this was a massive cult production for all this time. Yeah, I'm coming to the end here, but
I was talking to someone, and they were saying, they were talking about like space, how everything started, having a conversation about that. And they were like, oh, it started with dust, and then dust and dust, and it's just like.
yeah, this is all. Like everybody's looking for the beginning point and the Big Bang, and these things really don't exist. They come out of mathematical models that just have basically points where the formulas explode. They don't go anywhere, and they don't tell you anything causal. There's a great deal to be discovered if you look at these, like black holes. There's something that exists, but you got to look at it. You can't just leave it as a mathematical point. So this is now. Ask yourself, what's happening? We have a human species that has been able to discover the way the universe works, acts on it based on those principles, and has successfully, at some level, developed ever greater knowledge so that we can support more people who can discover more about the universe. And those laws and the process by which those laws are created in the human mind and in human society succeed. They work. The universe works the way the human mind works. Therefore, where did we come from? We came from, to the extent you could identify a species that begins to act that way, we came from the fundamental laws of the universe. We didn't come from an ape, even if there was an ape that was a transitional physical form that led in this direction. It may be the case. Just like the infant, the thing that qualifies a human infant is that the human infant's organism is appropriate to becoming, to development. It generates in the central nervous system and the somatic processes a capability to develop its central nervous system, its thought processes. That's the only thing that's human. That's your identity. The thing that throws people off is it is possible for human beings to act like animals. We do come out of physical forms of that sort. Therefore, we have to identify with that which makes us human to stay human. And the great thing about human beings is the only thing that could have ever made us happen is the underlying physical, developmental, universal principles which we are in the process of discovering. And if you want to know why, as Dante says, why should we go out there and discover these things? I mean, of course, we could do all this. We could go out to Mars. We could go beyond the heliopause and so on and so forth. Why? Because we'll find out who we are. Just like Dante did. What we're discovering in the universe is that which created us. And why not do that? Yeah, of course. We'd love it. Huh? It's sure more than making economic good in the sense of money, money, money. It's sure better than a degree. It gives you a great love for other human beings because they're all engaged, have that capability within them. You learn to love other human beings for what they could become. Then you're less worried about the problems that you have with them. Huh? They're not that important. You know, your girlfriend doesn't like you, so what? Yeah.
Put that schema, the schema that you're showing up there. I had a question. So in this, each little box, let's say, I mean, a lot of these things were discovered, classical humanist education, you know, the Brotherhood, the Common Life, and these guys were working on this. You know, you can look at FDR, and he was using this, they were using this during the machine tool principle and things like this. What's the principle that Lynn discovered, which organizes this, which makes this totally unique? All these ideas which you find, a lot of these ideas which you already find.
No, you don't. What you find in most of history is bits and pieces of it. The Brethren of the Common Life were doing certain things that were proper from the standpoint of classical history. Okay? If you want something more appropriate, Plato had an idea of the Socratic dialogue. He knew this was a way to generate hypotheses, and he knew this is the way science developed. Okay? What Lynn does that no one else does, and there's a whole array of elements of this, but the essential character of it is maybe best described by looking at the difference between Lynn and Vernadsky. Okay? Because Vernadsky's problem is, even though he's right about the role of noetic phenomena, he sees it, number one, as an individual thing. It's the individual's relationship to the physical universe. You generate the idea and you act on the idea. Lynn's point is that in a certain sense, classical artistic conceptions are a higher level than scientific physical principles, to put it that way, or science really is the combination of the two. Because classical art is the laws of the generation of new ideas in the human mind and the ability to communicate them to others, which means the human mind itself becomes part of the physical intervention into the universe. That is, the human mind developing ways of communicating ideas to other human beings is the way that you transmit universal physical principles, develop hypotheses. Okay? So what we've done now is what Lynn does is he takes everything outside the realm of experience and appearances. And it's all at the level of the human mind's generation of hypotheses and communicating them to other human beings, and now we have hypotheses about how to communicate them.
What about Beethoven's music? Beethoven.
No, he did not see that as a universal physical principle for changing all of humanity's relationship to the universe. He didn't.
Not his musical composition?
No. He sees it as uplifting people. There's nowhere that Beethoven talks about this as the governing principle for human economic development and relationship to physical nature. Schiller, see, here's the point. They have bits and pieces of it. Remember, the way you're looking at Schiller is from the standpoint of Lynn.
Yeah.
Franklin was an interesting character, I mean, no doubt. But Lynn's actually discovering that the noetic principle of the human mind is the governing principle of all of our relationship to the physical universe, and it's the only way to know the physical universe itself. I mean, in one sense, yes, I think some of the Plato has the concept, if you look at the Parmenides and the Philebus, but it's still at the level of the simple philosophical idea. Being is becoming. That's what Plato is all about. But Lynn is, in a sense, demonstrating this as a physical principle that's active in the universe, and that is our relationship to the universe. So he also generates a metric which no one else ever dealt with, but you can't deal with the number, which is the principle of relative potential population density. We can measure this. If you want to know one of the key things about it, we can measure this, provided we use it in the right way. One of the things I think that's totally unique about Lynn is that Lynn's point is that everything is intelligible. Everything. No miracles in that sense. It's intelligible. Even a miracle is intelligible. We can know why the universe produced that. What? Yeah, he believes in a God in the sense that I just described it. Yes. It's not silly. You don't really know what you're talking about. And to tell you something, it definitely beats dope. Okay? Go ahead. Because, look, there are times when the universe produces something that may be of benefit that we don't know the reason for it. But provided we are capable, we want to look at these kinds of things and find out how the universe works, we can eventually find out how that event happened. Yeah. 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 Yeah, there are reasons those things happen. And look, there is an element, although I don't want to say this is some kind of, because people deal with this stuff very mystically. But look, to the extent people really have a reason to stay alive, they in a sense want to stay alive out of a love for other human beings, to keep what they know alive for other human beings. There are times when one can marshal, though it won't work every time. So don't forget, there's a lot of times it doesn't work. But every now and then something happens medically, which is relatively unexplainable otherwise. But it always comes from the fact that the human individual and some of the people around that individual have fought to stay alive. And that's part of why it works. That's part of why it happens. Now, there may be other reasons, and you have to find that out. But there's no doubt that any decent doctor would tell you in their experience that the state of mind of the patient is some portion of the protocol to cure a patient if it's possible, or to save the patient. People who give up, give up. Yeah.
I just run into a certain paradox when we're railing against genetics, but there is a certain kind of genetic structure, there is a certain kind of like actual frame we need to support cognition. But that's not
Yeah, but,
cognition, right?
yeah, no.
But well, if you go from that, where do you get into like say a stillborn child or some body?
Well, a stillborn child is dead, right?
Damaged, like permanently, where there is no apparatus
Yeah.
for cognition.
Right.
Are they no longer human?
No, I don't think we would want to treat it that way.
Even, like, human respect.
We don't really know what that human being is capable of experiencing and not experiencing. It may be limited, but it may still be capable of even lower level cognitive acts. Like a lot of people who are mentally retarded are capable of doing loving qualities of things, and our respect for that may actually let them develop further. Plus, a lot of times with retardation, you have to be real careful, because it's also, and unless you're talking about something like an anencephalic or something like that, there's also always a complex mixture of how is the person related to, was the person loved. It's like this whole question of genetics. There's a role for genetics, but the genetics is subsumed within a much more complex area, so that even the way the genes work in the course of somebody's life is defined by mental activity, whether social activity, nutritional levels, medical levels. So it's never going to be a defining characteristic. I mean, you can say, people will then say, well, what about height and so on and so forth? Well, okay, but even that is only a boundary condition. Okay, and of course it's not even all that important. So yes, we respect the individual. Sometimes we even will bring out in a physically damaged person elements of human qualities which are related to cognition. For example, a severely retarded person can respond to being loved in a uniquely human way. And that ability to respond to being loved is a benefit to the people around it. Not in a human way, no. Not in the same way let me give you an example. Domesticated pets don't smile. And a smile indicates something. So what people try to do, is they try to reduce things to banalities. Yes, why are domesticated pets better? Because they're domesticated. They have a certain unique quality, particularly social animals, that are able to respond to something about human life. We do make them a little bit more intelligent. That's true. But they're not capable of the same pattern of responses to cognitive qualities that even a retarded human being is.
I was just going to make a point that, LaRouche is against this whole obsession with genetics, but at the same time, he's being somewhat of a geneticist by preferring Africans over African gorillas. Would that be...
No.
What?
No. He's preferring...
As far as human beings over...
Yeah. We have cognition. They don't. We're a different species. We're totally different.
But isn't that like a derivative of genetics?
No. The genetic code doesn't add up to cognition.
And then it goes back to...
Yeah. Cognition is cognition.
The genetic code no longer
Yeah.
supports cognition, but it's still fully determined.
Yes. Because you will find that even when the genetic code has damage in it, it still shows signs of cognition in most cases. Unless there just isn't a brain there.
If that was the case, then
Then it's not going to live very long, so that's that.
No, we should probably.
Yeah.
Has anybody ever worked with anyone?
Well, I have, but maybe other people.
Yeah, I mean, it's more than an animal.
Yeah, way more.
That's what my father did. My father's life work was working with mentally retarded children to teach language. And this was against the behaviorists and the Skinnerians and others who said, no, just give them incentives and treat them like animals. And my father's approach was, if you show love and human qualities to mentally retarded children, they'll develop language further than you ever would have thought. But they'll also, you don't need to lock them away and be ashamed of them. They're actually human. We should probably...
Yeah, but...
because the dinner is...
Yeah. There's more, but look, there's nothing, this doesn't lead to say treating animals like junk. You just treat them, you can treat them with respect. But you you recognize they're animals. They're not the same as human beings.
We're going to have plenty of time to continue this discussion over dinner, but we do have certain things, and Laney is now here.